This will be your last challenge of this particular chapter. What I have here are what I like to call density amplified problems. These are density problems that deal with our density equation, D equals M over V. But what I've done is I've also added some converting that you will need to do and some extra problem solving to work on problem solving skills that you will need to work through to do these problems. So what you want to do, and we should be almost out of sheets in our packet, so it should be pretty much the last sheet in the packet besides labs. You need to find the worksheet density amplified, and there are going to be two examples that I'm just going to work through with you and show you what you kind of need to do, and then go from there. So the first example that we have is this example right here. Okay, and these are going to be word problems. So the density of ethylene glycol, the principal component of antifreeze, is 1.11 grams per cubic centimeter. If you have 4.56 kilograms of a liquid, how many gallons do you have? And there is where this becomes amplified. Okay, so I'm looking for volume, because if you look at what your givens are, okay, it says the density is this. So in my givens, and this is where it's very important that you write out what you know, my givens are I have 1.11 grams per centimeter cubed. Okay? And then hopefully you understand that kilograms is a mass. So my mass is 4.56 kilograms. Okay? So what I'm looking for is the volume. And this is where I would definitely be putting what I'm looking for as a question mark. Now, there are a couple of issues that you have right away. Okay? If I'm going to take and solve for volume, I know density is mass divided by volume. So I know that volume is mass divided by density. One of the things that you're going to need to look at, first of all, is do units match? Okay, that's one of the first questions you're going to have to ask. And in this particular case, they don't, because you have kilograms and you have grams. So the wrong thing to do would be to go and right away and say, well, I can take 4.56 kilograms and divide that by 1.11 grams per centimeter cubed. I cannot do that because kilograms and grams don't cancel. So this is the absolute wrong thing to do. So in order to make this work, okay, I have to find a unit that matches. So the thing to do is to take one of these two and convert one of the units to a unit that matches. So what I would do is I would take the mass, 4.56 kilograms, and do a quick conversion here, where I know that 1,000 grams is 1 kilogram. And this is where a couple days ago I told you to memorize some of these conversions. If you memorized this conversion, you didn't have to take the time to look it up. So kilograms now cancel. So I know that this is going to be 4,560 grams. And one of the things to notice is, notice you didn't change your number of sig digs. Okay, you have 3 sig digs here, you still have 3 sig digs there. Now I can solve for the volume. So the volume is the mass, 4,560 grams divided by 1.11 gram per centimeter cubed. Now my gram unit cancels, so I'm very happy with that. And I'm going to get a volume of 4,110 centimeters cubed. Great. Okay, so I got my volume, except I didn't answer my question. my question said, how many gallons do you have? So now I have to do yet another conversion. I have to take this 4,110 centimeters cubed, and I need to convert that to gallons. Okay? So now you might need to go look at your conversion sheet, but hopefully by now you know that in order to go centimeters cubed to gallons, you're going to have to hopefully go to liters. 1 liter is 1,000 centimeters cubed, and 1 gallon is 3.78 liters. So I can use those two conversions, and I can now just make this conversion. And this is a simple conversion that by hopefully now we're used to. Okay, do some dimensional analysis, make sure your units work. And then do the math. And get 1.09 with correct sig digs gallons. So when I say density amplified, okay, it's the same density equations. You're just going to have to think and do a lot of converting along the way. So let's try another one here, okay? This is the second example on your page. Suppose your bedroom is 18 by 15 by 8. The density of air is 1.29, and we want to know what is the mass of air in your room, okay? So, some given information that I have, I know the density is 1.2929 kilograms per meter cubed, and that is the actual density of the air. And the volume I'm going to have to calculate here is 18 feet by 15 feet by 8 feet. So that's going to give me something in cubic feet. So 18 times 15 times 8 is 2,160 feet cubed. And then what I'm looking for is the mass. So my density equation is mass divided by volume. So mass, I know, is density times volume. Except again, I have a unit problem, okay? And I have cubic feet here, and I have cubic meters here. So I will not just directly be able to convert those two. So I'm going to have to take this 2,160 feet cubed, and I'm going to need to convert that to meters cubed. Okay, now, this is something we've done. You may need to look this up, but 1 meter is 3.281 feet. So, to make this conversion, 2160 feet cubed, I'm going to multiply by 1 meter over 3.281 feet, and I'm going to do that 3 times. Now, all these 3 feet on the bottom, cancel this cubic foot, and I'm going to end with units of cubic meters. And we just need to do the math. And that gets us 61 meters cubed. And now I can actually solve the original problem, which is take mass is density times volume. So the mass would be 1.2929 kilograms per meter cubed times 61 meters cubed. And that mass comes out to be 79 kilograms. Meters cubed cancels out. So, the rest of this worksheet is yours. Hopefully this will get you started.